Click the link in the description to download your own copy of this video's problem. Hey guys, Russ here. Welcome back to another fantastic chemistry video. And today we're going to do some more IUPAC naming of organic molecules. Only today they're a little bit more complicated, but not really. They're just a little bit more, they're just a little bit bigger. The rules don't change. So remember that. The rules don't change, guys. Just even if the molecules are big and intimidating, the rules never change. All right, so let's name this big molecule here on the left. Let's count our carbons. 1, 2, 3, 4, 5, 6. So the number to beat is 6. 1, 2, 3, 4, 5, 6. Number to beat, still 6. Remember, I'm trying to find the longest continuous chain of carbons. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is an octane. So the last thing out of my mouth when I'm naming this molecule will be octane. Now we have to number our carbons. And remember, when you start numbering, you always start numbering at the end of the longest chain closest to the first substituent. So if I started numbering here, call this carbon 1, this methyl group would be on carbon 2. If I started numbering here and went around to the first substituent, this would be carbon 1, carbon 2, carbon 3, and carbon 4. Okay? So obviously, starting here gives me the lower number because I get a 2 here. So number it like this. 1, 2, 3, 4, 5, 6, 7, and 8. So this tells me that on carbon 2, there's a methyl. On carbon 4, there's an ethyl. On carbon 5, there's another methyl. All right, so there's my root name, my octane, and my 3 substituents. I have 2 methyl groups on carbon 2 and carbon 5, and 1 ethyl group on carbon 4. So put it all together. So remember, when you have more than one substituent, more than one type of substituent, it has to be in alphabetical order using the letter of the substituent names, the first letter of the substituent name. So here we have ethyl and methyl. So E versus M. E comes first in the alphabet, so E comes first in the name. So it's going to be 4-ethyl dash 2, 5 dash dimethyl octane. Let me make that a little bit neater. There we go. So now let's go over that name real quick. 4-ethyl, so there's my carbon number 4, and there's the ethyl group. E comes before M, so E's first. 2 and 5 have the same substituent, so on carbon 2 and on carbon 5, there'll be a substituent, and they'll be the same thing because they're grouped. Di, there's 2 of them, so it's redundant. So there's two numbers here, so the prefix di has to go here. Methyl, so 2 methyl groups, 1 on carbon 2, 1 on carbon 5, no problem. And it's an octane. 1, 2, 3, 4, 5, 6, 7, 8. So this molecule is 4-ethyl-2, 5-dimethyl octane. That's how you would name this particular alkane right there. All right, let's do the next one. 1, 2, 3, obviously not right. 1, 2, 3, 4, 5. So there's a long one. 5 is the number to beat. 1, 2, 3, 4, 5, 6, 7. So 7 is our longest chain. Let's circle it. I guess we could do it from here, right? 2, 3, 4, 5, 6, 7. Let's do it from there. There you go. Now again, the rule is number from the carbon closest, carbon on the end, closest to the first substituent. So that's going to be here. 1, 2, 3, 4, 5. Oops. 5, 6, and 7. Now you might be asking, why did you number there? Because if you notice, going from here to here, it's carbon number 1 to 2. This will be 2-methyl. From here to here would be 2-methyl. But then the next substituent would be carbon 4, numbering from this side, right? So numbering from this side, it would be 2-methyl, 4-methyl. That's why. Because from here, it's 2-methyl, 3-chloro. That's going to give me the smaller numbers. It's always the smaller numbers you want, okay? So here we number from number 1. So this is a heptane, 2-methyl, 3-chloro, 4-methyl. So that's all the substituents and where they're located. Now let's put it all together. Well, C comes before M, so it's going to be 3-chloro dash. Now we have a methyl at 2, 4, and 6. 2, 4, 6 dash. Trimethyl. And this is a heptane. And that's how you would name that particular molecule. Now, the confusing part with this one, I'm going to go over it one more time, was the numbering system. Why didn't I start here? Because this, if I start from here, this will be carbon 2, and it would be 2-methyl. If I start from here, it would also be 2-methyl. So why did I start from here and not here? It's because of the next chlorine. When you have a tie going from one end or the other, you have to go to the next substituent. And when we do that, we find out the next substituent will be 3. Here it would be 4, so we had to come from this side. You always want these numbers to be as low as you can get them. Okay? So that's why I started from here and not from here. It wasn't the first substituent, it was the second one. Because the first one was the same numbers. Okay, I had to go to the next one to find the difference. All right, guys, I hope you found this video helpful. If you did, slap that like button, leave a comment below. Let me know how I did. Let me know questions that you're working on or things that maybe I can make a video for you, and we can help each other out in our endeavors to learn organic chemistry. And if you could, please subscribe to my channel. It really does help me out when people subscribe. It lets YouTube know I'm doing a good job. Please also share my content with your friends or family members who may be taking organic chemistry and may find my content helpful. And with that, you guys, I want to wish you all good luck and good chemistry. We'll see you soon. Email drbetts@protonmail.com if you would like a copy of every problem in this series.